add this off to the side here where you have this little blank space. What we want to identify is how many solutions do we have and what kind of solutions they have. So we have two solutions. So you're going to put two, and we're going to write these as two real solutions. So real numbers, long time ago, we did it a little bit. You would have had your number systems, wholes, integers, rational, irrational. Real numbers are every number you've talked about in your whole life up until this point. Everything is a real number. Okay. And they're also real, and these would be what we're going to call right now rational numbers. Remember, we started at the beginning of this chapter irrational versus rational. These are rational numbers. I could write this as a decimal if I wanted, but that decimal terminates. It doesn't go off, not repeating. So we have two real and rational numbers. And then highlight, circle, whatever. Notice what we get underneath the radical here. It's this nice perfect square of a positive 4. So when we get a nice perfect square, which we do here, this should always happen. We should get two real rational numbers. These are the nicest ones probably that we do. Okay. And we'll come back to that idea here in a minute and on Monday. All right, so go to number 2, same idea. Do the vertex and the x-intercepts. So the vertex, you can either look at the graph or you can look at your table, and in the table, find the middle point in that table. Okay, now Heilman. Do this again. What's the vertex of this one, Elizabeth? Good. Negative 2, 0. Did you use the graph or the table? Good. So if we just look at the graph, here is the vertex right here. Just identify what that coordinate pair is. The x is a negative 2. The y value is a 0. If we go to our table, this point right here is where we should see the symmetry around it. So 1, 1, 4, 4, 9, 9. So that tells us that that is our vertex. Okay. All right, Sophia, if I ask you what the x-intercepts are, what's our x-intercept, Sophia? Is that the only one? Good. So this only has one x-intercept. If we look, Maria, did you use the graph or the table? Okay. So if we use that table again, notice there's only one place where that y value is a 0. That's why we're only going to get that one x-intercept. Even if we look at the graph, I had you do this yesterday or 2 days ago with that little assignment. The vertex would have to be on the x-axis. It's the only way we can get one and only one solution. Okay. So we're going to do the quadratic formula. Watch what happens when we only get one solution. So let me write it here so we can see where it's all coming from. And let's do the quadratic formula with this. And now there's going to be something unique that happens this. I think this might be the first. I don't remember. We'll see. Go set this up. Let's not write the formula. We should know that at this point. So the 4 is your b. So negative b. So negative 4. Then you would have your b squared. And then minus 4 times a, which is a 1. And then c, which is a 4. And then all over 2 times a. Actually, finish that off and tell me what's now unique about this. Nothing crazy. It's, not going to be like a magic trick or anything, but something interesting should happen here. You got a question, Fabian? You're going to tell me it. Fabian, you have a question?
Yeah, I know.
Okay, hang on just a second. All right, Fabian, what is kind of the interesting, weird thing that happens here?
It'll be 16 minus 16.
Good. So underneath that radical, I do 4 squared, which is 16. And then I do a negative 4 times 1 times 4 gives me a negative 16. So the thing that's a little different here, I think this is the first time we've seen this. So we're actually done the quadratic formula with this. What do we get underneath that radical, Fabian?
0.
Good. So we get a 0 under here. So this is not a coincidence. If I get a 0 underneath this radical, so in the future, if that ever happens, the reason that's going to happen, or what that then is going to imply, we only get one solution. Here's why this is one solution. Let's kind of carry this out so we don't think this is any different than anything we've done all year. You're going to do -4 plus or minus, what is the square root of 0? 0. And then let's say we set up our two equations. If I do a -1 plus a 0 and divide by 2, and then I do a -4 minus 0 divided by 2, don't those both just give us a -4 divided by 2, and aren't both of those going to give you the exact same answer? Is that also your x-intercept that Sophia gave us at the beginning? Yeah. All right. So the x equals a -2 is that one x-intercept. All right. So right now, kind of a mental note, when we get a nice number underneath here, so this is a nice perfect square. These are probably the nicest ones. You're going to get two rational real numbers. If we have a 0 underneath this, then we are going to just get one rational. So it's not a coincidence. This will always happen. One rational number, and it is a real number. So that's 2 of the 4 things that can happen. All right, 3. A and B. Knock out A and B real quick. Try to. So go to number 3. All right, Amarian, what's our vertex for this one? Why do you think that? You use the graph or the table? What one do you want to use, the table or the graph? Okay, so I like the table too. So as we look at this one here, which point has that symmetry where the number in front of it and behind it is the same? And then 2 in front, 2 behind it. There you go. So -2 and -2. So if we look at this point right here, this is the one that has the symmetry we look for. -1, -1, 2, 2, 7, 7. If you look at your graph, just find this lowest point. That's the second negative tick mark. So that's a -2, -2. So good. We got there. So if I ask you what your vertex is, that's a -2, -2. X-intercepts. What do we think about those? Do we have them in this problem? Do we cross the x-axis? Yeah. So in terms of these, if we just look for the y value of 0, do we see any y values of 0? No, that doesn't mean they aren't there. They could just be a decimal. So let's look at our graph. Does this graph cross the x-axis? Yeah, and how many times does it cross the x-axis? Twice. So our x-intercepts are here and here, but as of right now, we don't know what they are. It's about a -0.5 if we look at this first one, somewhere right around the -0.5-ish, but we wouldn't want to assume that it's a -0.5. We don't want to guess. All right? So until we actually solve this, and the way we're going to solve it now, because now we don't know what this answer is, so now the quadratic formula is necessary, we don't know what these are. So let's set this one up. X squared plus 4x, and then what did I do? So we should get -4 plus or minus, and then that b squared minus 4ac, and then all over 2 times a. Clean that up, and then see what kind of number we get underneath here. If it's a nice number, we should be getting 2 nice numbers. If it's a 0, you're only going to get 1 answer. So now clean that up, kind of see what happens with this. All right, should get 16. And then the negative 4 times 1 times 2 should give us a negative 8. So underneath that radical, we get an 8. Okay, I'm going to highlight this. We're going to talk about this in a minute because this is when we want to kind of understand why we're going to get the numbers that we get. Is that a nice perfect square? No, and that's okay. We know how to handle these. We've done plenty of these over the last 2 weeks. This is when we have to find numbers that multiply to be a root 8, with one of them being a perfect square. It's probably the easiest one you could come up with. We know that's got to be 4 and 2. And then what's the square root of 4? 2. I'm running out of room, so I'm just going to erase this and make that a 2. And then these, well, let's actually simplify this. I had you do this yesterday on that computer assignment just to see if we knew how to do this. So this is okay, but on the test next week when you have some multiple choice, we want to recognize that this can reduce because all 3 of these non-radical terms, what can they all be divided by? 2. So we want to reduce all of those by a 2. So take the negative 4 divided by a 2, and then your plus minus 2 divided by 2 is going to give you a what? A 1, and then leave the root 2. Same on the bottom, 2 divided by 2 is going to give you a 1. The one yesterday was very, very similar to this. And then when I wrote that answer, if I ever have a fraction and the denominator is a 1, we don't really need to write that. So we really would just write that negative 2 plus or a minus 1 root 2. Yeah. You don't have to write the 1 either, so I can get rid of that. I think on the one yesterday I did not put that. Notice this is 2 solutions, although I ran out of room here. So this is 2 solutions. Let me kind of show you how this is 2 solutions. One of the solutions would be a negative 2 plus the root 2. The other solution is a negative 2 minus a root 2. So that's still 2 answers. Let me plug one of these in. Let me plug in this one. Actually, I already did it from first period. Oh, no, I didn't. Where is it? Yeah, right here. So if I go to this negative 2 root 2, that's one of our answers we just got. When I enter that, see how that's that negative 0.5? Isn't that where we said one of these is crossing the x-axis at? Right around a negative 0.5, this one right here. So that's one of our answers. So what that allows us to do, go back up to letter B. I can now state what my 2 solutions are. One of the solutions is, so we're just getting them from down here. These are your 2 solutions now. A negative 2 plus root 2. And then a negative 2 minus the root 2. I guarantee if I plug this one in, it's going to be about a negative 3.5 because that's where we're crossing the x-axis at. All right. So now, how many solutions do we have? 1 or 2? We have 2. So we're going to write we have 2 real solutions. So they're still real numbers. Every number you've seen in your life we consider in the real number set. However, these are also, notice when the calculator, we plug this in. Notice how this is a decimal that doesn't repeat. There's no pattern here. The only reason it ends is because the calculator screen ends. So this is an irrational number. Anytime I have a square root of a non-perfect square, the previous couple, we've been saying they're real numbers, but we've also been saying that they're rational numbers. That's not what we have here. These are 2 real numbers, and they are irrational. That's going to happen whenever, right here, this root 8, whenever we get a non-perfect square, we're going to end up with 2 irrational numbers. Okay, this is a heads up. All right, last little combination. Do 4. Go all the way through that one. So write the vertex if you can do it. Tell me what you think the x-intercepts are if you can do it, and then solve the quadratic formula, and then see what happens here. Is that enough? Okay. Henry, are you good so far? Somebody,
They don't have the.
oh, I see. Yeah, it's x squared plus 4x plus 5. That's a good call. That's your equation. X squared. That's an x squared also. There we go. Yeah. Yeah, I want you to kind of go all the way through this one now because something else unique should happen here that we haven't, that I've been telling you should have happened. Okay, I'm seeing people get there, so let's get going. I don't want you to go too far because there is something weird going to happen that you haven't seen yet, and we want to talk about what it means. All right, so part A, vertex. Catherine, what was it? Good. -2, 1. We can either look at our table. That's the symmetry around this, or just look at your graph. X coordinate here is a -2, y coordinate is a -1 or a +1. If I ask you for your x-intercepts, Maria, what are they? Good. That never crosses the x-axis. So we talked about this the other day. The other day I had you write no solutions. So let's go to the bottom where I've having you write these solutions in. Go ahead and put there are no, but what I want you to write down here, we're going to add the word real solutions. There are no real solutions because the real solutions are when we cross the x-axis. All right, and clearly that does not happen. There are no x-intercepts. Let's see what causes that issue. So if we now go through the quadratic formula, x squared plus 4x plus 5 is the problem. I would have a -4 plus or a minus the b squared and then -4 times a times c and then all over 2 times a. So far, nothing different. As we go and clean this up, 4 squared should give us a 16. The -4 times 1 times 5 should give us a -20. And then all over 2. I've been telling you this can't happen. I said eventually we will, but up until what we've been doing, I said you shouldn't be getting this. If you did something wrong, what do we get underneath the radical? Good. So that is not incorrect now. All right. Notice how this is a -4. Notice how in this graph, do we ever cross the x-axis if we get a negative number? No, that's why. There's a problem here. However, that doesn't necessarily mean we're done. So let's talk about this first of all. If I throw in -4, square root of a -4 into my calculator, notice how it says no real answers. That's what we just wrote down. All right, non-reals. There are no real solutions to this. All right, the reason for that, make sure we understand this. When I do the square root of 4, isn't that asking what number gets multiplied by itself to give you a 4? So if I give you a -4, is there any way to multiply a combination of 2's that are identical and give you a -4? No, because one of them has to be negative. That's the only way we can get that -4, which means they're not the same. So that's why the square root of a negative number is a problem. Okay, we can't take the square root of a negative number in our normal number sets and say that there's an answer. Okay, so for right now, we're going to leave this, and then we're going to come back after we do something on the next page. All right, so that square root of a -4 is a problem. So go to the next page, number 5. Write down what our problem is. So we got this guy Israel. He's concerned about what happened in number 4. So if you understand what I just said 30 seconds ago, what's our problem with this? All right, why is Israel concerned about what happened in number 4?
finish the problem?
Why did we not finish the problem? Why did we stop with that problem?
That's one question.
Riley. All right, you're going to expand on that, right? There was a negative what? Good. There was a negative, I'm going to write it this way. There was a negative number under, and then what Riley said, the square root. Right, that's our problem. And that's why we stopped temporarily with that problem. So if we get a negative number, there are no real solutions to that. The next question, it says, what happens when we get a negative number underneath the radical? What that means is we are going to change from the number system that everything we've done up until this point you've dealt with, the real number system, to what we call the complex number system. What that also is referred to as, so write that down. So we're no longer dealing with real numbers. There's a separate number set altogether called complex numbers. What those are also referred to sometimes are imaginary numbers. Then underneath that, what this whole complex system is based off of is the idea that if I ever have the square root of a negative 1, in the current real number system, that's impossible because I can only get a perfect square if I'm multiplying the exact same number by itself. Well, if they're both positive, I get a positive 1. If they're both negative, I get a positive 1. The only way we can get that is if one's positive and one is negative. And are these any longer identical to each other? No. So that's why we can't do it. So what the square root of a negative 1 is defined as, and this is why they use the idea of the word imaginary, even though it's really a complex number, is the letter I. So whenever you see an I, it's actually a number that refers to this idea of a square root of a negative 1. Okay? So what that means, go to these next set of problems, these 4 problems right here. So remember, we just wrote the square root of a negative 1 is given a value of I. So in number 4, here's how I'm going to have you set this up. The square root of a negative 4 is not a real answer. We just showed that here. It's not in our real number system. That's why you get that error. What we're going to do is split this into 2 radicals like we've been doing. Make one of them a negative 1. Make one of them a 4. All right. Then 1. What do we know the square root of 4 is? 2. So that still becomes a 2. All right. So this is our 2. But now we also now have this square root of a negative 1. And anytime you see the square root of a negative 1, that is equivalent to an I. So you're going to write this as 2I. All right, and then that's our answer. If I give you a negative 16, same thing. Let's actually put the 16 first and then put the negative 1 second, just since that's how we want to write it anyway in the final answer. All right, Mark, what's the square root of 16? 4. And then what we just said here is, here's this little square root of a negative 1. That is the number I. So that is 4I. These won't all be perfect squares. So let's say I go ahead and 12. Normally, I would do 4 and 3. So we're still going to do that to break down to 12 since it's not a perfect square. But since it's a negative 12, we're going to add a third radical with that little negative 1 behind it. All right, Riley, square root of 4 is what? 2. And then that root 3 we can't do anything with. So you're still going to have 2 root 3 like we have been this whole time in the last few weeks of doing these. But then we see this little root negative 1. So that's going to be your I. So we write that as 2I times the square root of 3. All right, 4. If I just gave you 50, again, this should be a nice one, 25 and 2, I think we'd come up with pretty quickly. That's a positive 50. We have a negative 50, so we're going to write this as a negative 1. All right, write that answer then. Write down what we're going to put that as our answer. Diana, what's the square root of 25, Diana? What is the square root of a negative 1? Okay. Thank you, Diana. And then that root 2 you can't do anything with. So we'd write this as 5i root 2. Okay. So what I want you to now do, now that we've seen this, go back to number 4, and we're going to finish this problem. So if I now had you do this problem again, we now know how to handle this guy right here. That is a 4 multiplied by a negative 1. So we're going to split that up. And you're going to have a negative 4 plus or minus. The square root of 4 is still 2. We now know that the root of a negative 1 is our letter I. And then all of that divided by a 2. This is one that would simplify. All of these are divisible by what? 2. So divide all of them by a 2. So the negative 4 divided by 2 is a negative 2. This 2 divided by 2 is a 1, so 1i. And then in your denominator, you just get a 1. Since your denominator is a 1, we don't even really have to write that in. This is still 2 solutions. So I'll show this one more time with the i's. Negative 2 plus I is one of our solutions. And then the other solution is when I do a negative 2 minus an I. So this is still very much true, just like I had you do on the assignment the other day when I said write no solution for this. So the whole little, this whole idea that there's no real solutions, that is still true. If this comes back to me, what I'm going to have you write is, but we do have 2 imaginary solutions. Okay, if this will work. All right, I don't think it is. So underneath this, you're going to write the word but with 1 T. Okay. And then you're going to put, there are 2 imaginary solutions. Right, and I can't write it, as you can see, because I got the circle of death happening right now. And we will know that when we start getting these square roots of negative 1s. All right. Let's pass it out while I try to get word back. All right, so now, homework. Let me pull this up, and then I'll tell you what you're going to be doing on this. I don't think this is going to work. Let's... All right, on the homework, you're going to do 1 through 5 first, once I find it. So don't worry about the ones at the bottom. Just show me 1 through 5 that we can go through those. And then, so numbers 1 through 5 only. All I want you to do, don't worry about this word discriminant yet. We didn't quite get to it. All I want you to do is solve all of these with the quadratic formula. So it's just 5 quadratic formula problems. But what I want you to now do is do what we did in all those problems. Tell me what kind of solutions we got. Did we get 1 solution? Did we get 2 real rational solutions, or do we get 2 imaginary solutions, the stuff that we just kind of talked about? So that's all you're doing, 1, 2, 3, 4, and 5. And then you're going to tell me what kind of solution, how many we got and what kind we got. All right. And then we'll go over this on Monday, or I'll collect it on Monday. All right. So that's your homework 1 through 5 only.
What's the formula? I know it. I just
Henry. Well, share it for everybody else in the class.
I just don't want others to fall in line.
What's that?
I just don't want others to fall in line.
Yeah. So give it to him.
Is B
Henry, I'm writing it for
plus
you.
or minus negative B plus or minus squared b to the second power minus 4 AC over a 2A.
Thanks, Henry. Appreciate
No
it.
problem.
Now everybody's not going to fall behind like you were concerned about. That's nice of you. Yeah, there's your formula.
I just wanted to say it slow for everyone. So
Appreciate it.
they're copying it down.
Yeah, you got Diana behind you. You want to talk slow.
I was stretching my bed.